Can you hear me? Okay. Right, so on behalf of Swansea University and the Zienkiewicz Lecture Committee, I am delighted to welcome you all, both the audience here in the Waterfront Museum, as well as people who are watching online. So for the first time, we are also streaming this live, just for your information. So if you don't know me, my name is Perumal Nithiyarasu. I am the Associate Dean for Research, Innovation, and Impact in the Faculty of Science and Engineering at Swansea University. I also chair the Zienkiewicz Lecture Committee. Before I request Professor Paul Boyle to introduce our speaker today, our Vice Chancellor, Professor Paul Boyle, I would like to say a few words very briefly about the Zienkiewicz Lecture. Zienkiewicz Lecture was started in 2017 as a public lecture by a prominent researcher, as well as somebody who is actually working with governments, etc., to come and deliver this lecture to the public. If you are not familiar with Zienkiewicz, Professor Zienkiewicz was a professor of civil engineering at Swansea University. He also served as a head of civil engineering department. That's internally. Externally, he's very well known as one of the three founders of the finite element method. You may ask what a finite element method is. I think many of you are familiar with finite element method, but if you are not familiar with finite element method, this is one of the methods which completely changed the way in which we model many of the engineering and science problems. So majority of at least the engineering industries now use this method in order to do the design. I think lots of things have dramatically changed as a result of the finite element method. So when I think about the finite element coming out of Swansea, and Swansea is treated as one of the founding places, it makes me really feel very proud of Swansea's achievement. Now, the success of the lecture is often depending on the lecturer. It's no pressure, Jim. So we have a fantastic speaker today, and I'm not going to really say much about the speaker. That's why I am going to invite Professor Paul Boyle, our VC, to introduce the speaker today.
Noswaitha, and welcome everyone this evening. Good evening. And thank you very much, Arasu, for introducing the lecture to us. And I do remember you giving an introduction, must have been a few years ago, last time we were here for a lecture of this type. And it just reminds me that it's great to have everyone back in the room together, being able to listen to a lecture in this way. It's also good that we've changed our systems and now we're able to do it in a hybrid way. So we've opened up to a much bigger audience, which of course we wouldn't have thought of doing a few years ago. It's obviously my great pleasure to welcome Jim, Professor Jim McDonald, to give our Zienkiewicz Lecture this year. I met Jim many years ago for the first time when I was working in St Andrews, and I think it was probably 10 or 11 years ago, I'm not sure. That gives you an indication of how long Jim has been leading what is one of the most distinctive universities in the UK. We all know what we imagine when people talk about Strathclyde University, and if you think about it, there are only a small number of universities in the UK that have a really clear, distinctive identity. And I think Jim has done an absolutely remarkable job of carving out that identity for Strathclyde University. One of the things that I often say, and Jim, this is not that we're trying in any way to claim that our achievements match those of Strathclyde, but I often describe to people that I think Swansea actually is the Welsh equivalent of institutions like Strathclyde in Scotland and possibly Warwick or Sheffield in England. And I think one of the things we don't demonstrate enough, and actually if you look at the data you'll find out that we do, we collaborate with business more than nearly every other university in the UK. Our grant income in collaboration with industry is enormous. So there's much that we need to do to get close to what Jim has achieved at Strathclyde. But I think one of the things we do need to do is celebrate our ability to engage and interact with business in a lot of the work we do. And that comes, frankly, from the beginnings of this university, set up by industry for the region, and we're still doing it today, which I'm very, very proud of. However, today is all about Jim. He has a very long list of achievements. I'm not going to read them all out. He's a fellow of the Royal Academy of Engineering, and I think I spotted that he might be wearing Royal Academy of Engineering tie, which is making me feel very guilty that I forgot to pick up a tie as I left my office today. Royal Society, a fellow of the Royal Society. I could go on through the list of accolades that Jim has. It's a very, very long list. Critically, Jim's here to talk to us about a topic I think we all will realise resonates very strongly given everything that's going on at the moment. A whole systems approach to achieving net zero, a 21st century system. If we think about how many colleagues in our university and Jim's university and indeed across the UK are all grappling with the issues around net zero, how we deal with that problem and how we persuade the politicians and others to deal with that problem, it is absolutely one of the biggest issues we're facing today. So, Jim, I'm really looking forward to hearing what you have to say around this topic. So it's a privilege for me to be able to introduce you, Jim. I'm really pleased that you were willing to come all the way down from Scotland to join us. I know many in this audience are really excited to hear what you have to say. And of course, after your lecture, we'll enjoy very much having dinner with you. So over to you, Jim. Thank you very much indeed.
Well, thank you very much, Paul, for those kind words. And it's a great pleasure to be here. Another one of the Celtic nations. I was going to put my kilt on tonight, but I saw one of the audiences already beat me to it, so I'm feeling very much at home. Paul, may I also say, in turn, I'm a great respecter of Swansea University and your leadership and what you've achieved with your team, so I feel very much at home, not only in the place, but also with the folk that are here in the room. And as you've heard, I'm going to touch on something that is, I mean, there isn't a day goes past at the moment. Let me just make sure that we get on to, I'm going to let our technical expert do this. Just my digital input might be a problem. Is energy. Most importantly, we're seeing the terrifying ripples of the horror of war in Europe again because of what this illegal action on Russia's part going into Ukraine has done in terms of energy security, energy costs, and how that's rippling right through. I mean, by the way, if there's ever a systems effect, look at that. Major political aggression that's been subjected on Ukraine, and here we are feeling the impacts of enormous rises in energy costs, affecting the cost of living, supply chains, all the way through to energy security. But let's hope, for the sake of everyone, not least of which are Ukrainian friends and colleagues, that is resolved as quickly as possible. What it has done, I think, an unintended consequence, is I think it will accelerate us into recognising we need to decouple gas and oil away from our fundamental requirement for energy and secure energy. May I say as well, it's a genuinely great honour and privilege for me to deliver this lecture tonight in memory of Professor Zienkiewicz, a renowned contributor to engineering and the mathematical modelling that sits behind it. So it's something that is very dear to my heart as well. So let me take you through a whistle-wind tour of energy and my perspectives of it. I'm an electrical power engineer, by the way. And I've worked in the utility industry for a decade before I went into academia, and I hold the Rolls-Royce chair in electrical power systems. But fundamentally, I'm an energy and power systems guy. But let's remember some of the context here. We recognise this iconic individual, Greta Thunberg, a bold young woman, a woman that's now become a very important international reference for doing the right thing and acting as quickly as possible. I was watching her earlier this week in the run-up to the Sharm el-Sheikh COP27 conference. And she's an articulate, passionate, dedicated young woman, and we have to give her credit for that. And this was her starting in her school strikes, and all of that was important. Triggered lots of protest. And society is not passive in this space, and nor should they be. I'm the father of 3 children, all of whom are engineers, by the way, but that's another story, who have a much stronger moral compass than I had when I was their age, and they're all working in and around the energy industry. So as they apply themselves, they have a purpose, and the purpose is helping deal with climate change. And Extinction Rebellion, you know, whether we agree with our means, is another channel through which the voice of society is being heard. Many comments have been made. The Royal Society of Edinburgh that Paul has mentioned, Paul's the association there too, wrote a very good report 2 or 3 years ago, just getting that seminal overlay into energy systems and what the future of energy might look like. Committee on Climate Change, very important, Dame Julia King, very beg your pardon, Baroness Julia King sits on the Committee for Climate Change. One of my colleagues, Professor Keith Bell, is there, led by Chris Stark, who I worked with very closely. I co-chair the Scottish Government's Energy Advisory Board with the First Minister, Nicola Sturgeon, and worked closely with Chris before he went down to be CEO at CCC. And Chris, with input from me and others, came up with this notion of an energy systems approach that wasn't just a single vector of grid or renewables or you know, carbon capture and storage, but there was a systems perspective that one had to take. And I'm sure there are many engineers in the room here, and I'd be presumptuous enough to say that we sort of think in a systems approach to get that interconnectivity. COP26, I was absolutely proud that my home city of Glasgow hosted it last year. You know, the Glasgow Climate Pact, I hope, becomes a very important reference in the decades to come, where we got action really to the front of the agenda. I'm privileged to see a friend of mine, Lord Nick Stern, who's actually in the COP27 meeting as we speak, said that it was an interesting meeting insofar as that the world's business community went there as well. It wasn't just the policy makers, they had to be there. The world leaders, they had to be there. And it wasn't just you know, those that led sustainability for the companies. The chairs were there, the chief executives were there, the CFOs were there, because the need now, as we would understand, is to drive forward to action and delivery and change. And let's hope that what we see in the next 10 days lives up to that, because the world is watching COP27. Our new Prime Minister, a bit of a false start, originally not planning to go there, is there now. So that was unfortunate, but now he's there. We need to hear his voice. And Alok Sharma has now handed over the presidency of COP. But we can't say in the UK, well, that's us, we've done our bit. We now need to redouble our efforts. And to his credit, Mr. Sunak did talk about now committing to that, our contributions to that $100 billion a year investment to go to the developing nations to help them decarbonise. The Royal Academy of Engineering, where I'm president of the Royal Academy, I'm very privileged to do that, has had a very significant pipeline of reports and evidence to inform UK government and beyond. And last but not least, the Intergovernment Panel on Climate Change is continually telling us that we must get down to 1.5 degrees centigrade temperature rise, post-industrial, if we're going to have any hope of resolving some of the major challenges that we're seeing is affecting all of our lives. And did you hear what Guterres said at the start of the week? Remarkable language that he used. Remarkable. And I had to look a couple of times at what he was saying, that we're on the road to climate hell and we've got our foot on the accelerator. Now, he didn't, I'm sure he thought long and hard about that language being used. And it actually makes the hair on the back of my neck stand, and then just now even repeating it to you. That is a stark warning to us, stark warning to humanity, that we have to really move to action. The political rhetoric is important because it sets an agenda, but it's very much insufficient. It's necessary, but insufficient. What is sufficient now is getting about the business of rectifying us to a new low-carbon future. Busy slide, forgive me. So we've got lots of convergence here and pressures, and if I start at 12 o'clock and work my way around quickly, so lots of energy policy commitments, and to the credit of the UK government, one of the first to make, a large nation, to make a legally binding commitment to get to net zero by 2050. Good. Growing social conscience and awareness. Again, we can't ignore the fact there are still surprisingly naysayers about that look at the data and come to an odd conclusion that this is natural Earth cycles, where it seems to me that there's palpable map from man's contribution and impact on climate. and people are aware of this. Technology pushes there. Well, it's renewable technology, digitizing and automating, which is also a big part of decarbonisation, and lots more. Energy systems, which I'm going to major on over the next 40 minutes or so, is that integration of heat, electricity, transport, built environment, and policy and society engagement. Sustainable energy. This isn't just for us as an industrialised nation. We must show the socially progressive attitude to bring the rest of the world with us. And how challenging it is for us to say, well, over the past 150 years, we've used hydrocarbons to drive and build our economy, but you in the low-income countries can't do that. It's immoral, it's unnecessary, and that's why we need to get this investment on the part of our industrialised nations into the rest of the world so that they can build their economies in a healthy and sustainable way and learn from the lessons where we made mistakes. Cities, major importance here. I'll touch on that. And around energy, as I say, I'm an electrical engineer. I mean, the distribution networks that will be around Swansea, Cardiff, I'll tell you, a lot of the distribution network will be, 50, 60 years old. And that is one little example of ageing infrastructure. We can see, we're going to be out of coal, out of coal generation plant in the next 2 or 3 years. That's been a UK government commitment. And if we look around us, that we have a need to invest in what we have to do. But very importantly, I would suggest we have to acknowledge the effects of climate change and global warming. And I always, a bit of alliteration, we need the 3 Ds of decarbonisation, decentralisation, and digitalisation. And as I say, we've made legally binding commitments to achieve that, and that's good. And we need to make sure the measures are there. Chris Skidmore, who many of you know, who's an ex-science minister, an ex-energy minister, is currently doing a review of the UK government's net zero strategy. I've had a couple of engagements with him in the past few months. He's doing the rounds. I dare say he's either been to Wales, Paul, he'll be in Wales soon. And one question I posed was, well, is this us thinking about reversing off some of those challenging targets? And Mr. Skidmore assures us that this is about prioritisation and delivery and making sure that the process of getting to those net zero targets are tractable. So let's hope that's what actually emerges. Because overarching here is this notion of an energy trilemma. I'm an engineer, I'm going to ruin the English language for a couple of minutes, bear with me. So we've got a trilemma here. We've got these competing forces of a requirement to decarbonise, as we understand, in this process of dealing with climate change. But then security of supply and reliability is going in the other direction. There's always this question posed about wind, for example, about intermittency. And you may have seen reports in The Economist this week about Europe is going through a rather calm wind season at the moment, just as we're coming into winter. So there's an issue we need to think about. But if we start coupling that with other sources of energy, back to a systems approach, coupling in energy storage, we can mitigate that intermittency. But reliability is a key, and of course then we have to think about affordability and cost. When I'm talking to government officials and ministers these days, I am majoring on energy security, because that is naturally front and centre of the thinking, given all else that's going on in Europe. But if I now introduce a quadrilemma, or indeed a quintilemma challenge, if there is such a thing, we have to remember public acceptability is key. And the social dimension of, can people afford to go on this journey of decarbonisation? We can hardly afford to heat their homes just now. Can they afford to get electric vehicles? Well, probably not. Can they really afford to make their homes more energy efficient? Probably not. So they have to be given assistance to do that. And the other piece I would say, and I tip my hat here to Lord Nick Stern. So those of you that are in the energy domain might remember 16 years ago, the eponymous Stern Review, which was commissioned by Tony Blair, was about the economics of climate change. And Nick did a spectacular piece of work, which still stands to this day. He was in Glasgow with me just last week, but we're talking about it. That's about building economic opportunity, building new industries, creating new markets as we create a new decarbonised system. Remember, we had to do this. When we built all the power stations in the early part of the 20th century, we had to start from scratch. So we've got more technological sophistication. We've got much better understanding of the need to do this. So these challenges are always there. What are our options? What's it going to cost? And are they going to work? Again, I'm sorry for those of you at the back, I do beg your pardon. Another busy slide, but amongst many other things, there's been a lot going on these days. One that I'll point to is that the Prime Minister, i.e. Mr. Johnson, published in the run-up to COP26, the 10-point plan was published around a green industrial revolution. The net zero strategy went out there. Mr. Kwarteng, before he briefly was Chancellor of the Exchequer, when he was in Bays, led a lot of really good work on energy, around offshore wind now being ratcheted as a plan to 40 gigawatts by 2030, hydrogen, 5 gigawatts production, which is good, but that's at least an order of magnitude or more lower than it needs to be over the next 7 or 8 years, and I'll touch on hydrogen shortly. Nuclear advanced modular reactors, small modular reactors, that's about 200 to 400 megawatt scale. Now, we know how to build these small modular reactors. Rolls-Royce have been doing it for decades in Rainsway, down in Derby, but for naval applications. So it's now about industrialising those, and so on and so forth. Another very important piece of work was through the Council for Science and Technology. I sit as a member of the Prime Minister's CST, and about just over 2 years ago, I'm losing track of time, it was just as COVID was starting, so that's nearly 3 years ago, my goodness. CST published a report to Cabinet about achieving net zero through a whole systems approach. And I don't mind telling you, the engineers had a disproportionate role to play in trying to suggest that integrated systems-wide approach, strengthening institutions, frameworks, and leadership across government. Because when we talk about systems, it's not just about power systems and physical infrastructure. It's about the systems of government and governance. And in government, again, I'm not going to be overly critical, but they, as often happens, work in silos. And if we are going to take that energy systems approach, we need Treasury to be working with Bays, to be working with the Department for Communities, etc., and all the way through to how things are invested in. Get much deeper analytical capability into government so that they can not just think about but model alongside external advisors, but inside their organisation have strong engineering and science capability. And Sir Patrick Vallance, who it was my pleasure to induct as an honorary fellow of the Royal Academy of Engineering just last night. I told him it was a pinnacle of his career now, joining the engineering community. Don't know if Patrick completely agreed with that, but he's been a great advocate for engineering and science and policy making, and also maximising use of technology and creating the financial structures. We're talking about, according to Nick Stern last week, he thinks we need to be spending about $2 trillion a year. $2 trillion a year on revolutionising and decarbonising global energy systems. Now, eye-watering, incredible. However, the other side of that is it's probably 10 times that of cost on health, on flooding, on missed opportunity, and building new industries. So let's bear that in mind. They're massive numbers. But the other side of that is the cost of the irreparable damage and the cost of climate change means that this is, it seems to me, an investment worthwhile making. And I commend to you a report from the Energy Systems Catapult. Excellent capability in there, one of the UK catapult networks, estimating to 2050 we could require 2 to 3 times the current electrical generation capacity in the UK, because heat's going to be more electrified, transport is going to be increasingly electrified, we need to replace aging assets. So installed capacity, I should know this number off by heart, it'll be about 100 gigawatts or so. So we're talking about going to 200 to 300 gigawatts of installed electrical generation capacity. Is it going to be in the old way? Probably not. It'll look a bit like it, but we'll have to then think of an inversion issue. I'm going to start playing the bagpipes in a minute, Paul, forgive me, but in 1926, a Scotsman, Lord Weir, was commissioned by the UK government to come up with the Electricity Supply Act, which really went from lots of little municipal electrical power systems to an integrated, what he called electrical gridiron of connections, hence the grid. So understanding that vision, that policy commitment, that government commitment, the business and industry view, and then the technological innovation investment sits behind it, we're going to have to do that again. Nuclear is, I'm pretty sure, is going to play a significant part. It's been interesting for me in the past year and a half. Nuclear has sort of slid into the debate without an awful lot of public debate and discussion. I support nuclear as part of a decarbonised future, and we'll need to see, is it more large-scale pressurised water reactors or new reactors, or are we really going to get a new, alongside that, a new generation of small modular reactors? And bioenergy and carbon capture and storage, BECCS as it's called, another important opportunity for the UK to innovate, deploy, and then get commercial benefit as we go around the world. And I now see, Paul, some EPSRC and others now getting ready to get us going at low TRL capability around direct air capture using chemical means by which we can take carbon out of the atmosphere directly, having these large chemical systems and lots more. So there's lots going on, and that's good, but we need to move to action. So let me give you what do I mean by systems? And again, there'll be systems thinkers in the audience. And let me give you a little example from the Royal Academy's National Engineering Policy Centre. Systems approach fundamentally means about taking and integrating the various components of or the active parts of a system and recognising that there's very rarely one strand to get you to a solution. There's lots of multiple interfaces between either solutions or interplay between factors, and understanding the interdependencies. So again, in energy, it's not just, well, renewables. Renewables are going to be really important and are really important. But you can't think about that without thinking about grid infrastructure, and you can't think about that without thinking about energy storage. And then what about the uses? What does this mean for built environment, for example? So the net zero in the UK by 2050, China by 2060, means that we're going to need rapid and simultaneous transformation in big complex systems. Machinery of government, investment mechanisms, technological deployment, and quite frankly, our behaviours and the way that we live our lives. Lots of important interactions. And it's very important that these actions are coordinated. So you need a plan, you need a system architect, and you need something that outlives the period of a government 5-year period or less, depending on what's going on in the country at any given time. So we need to think about that. And without a systems approach, then unintended consequences can happen. So, for example, a housing design, depending on new commercial development, unless we imagine that it's going to have hydrogen and energy storage and electrical supply for vehicles, are going to lock that away from the potential benefits of a decarbonised transport system that sits around it. So there's a whole, by the way, a lot of these things I'm referring you to the Academy. Please go onto the Academy's website, look for the National Engineering Policy Centre, and you'll see a stream of what I am confident are very, very good reports. And back to Systems Thinking 101. This is generated by Professor John Clarkson, who many of you might know. He led the engineering assessment through REF. John, fellow of the Royal Academy of Engineering, did some work alongside our colleagues in the Academy of Medical Sciences and the Royal College of Physicians to get a systems approach in health. And it's cartoonish, but it's this notion of recognising from a system perspective in complex systems, here the body and energy, generation, transmission, utilisation, built environment. There's lots of interplay and interconnectivity. With the body, it's the circulatory, digestive, nervous systems, muscular, skeletal, lots of interdependencies there. If something goes wrong, it has massive impact on the rest. So it's a dramatic way in which to talk about the interconnectivity of systems. But the big point out of this report, which was, by the way, called Engineering Better Care, which was that systems approach to health and care design. Basically, big 4 components that makes up the system is people, of course, and I'll talk about skills shortly, systems themselves, subcomponents, the design and risk perspective, because the system that you produce, depending what your risk appetite is, and there will be risk appetite for the choices we make in the coming decades around energy and its redesign, that will lead up to the system. So our thanks to John, a great systems thinker, and it's that approach that we've been taking into energy. And you're never going to see the detail, even from the front table, so I do apologise. I'm just giving you a sense of complexity. This was a first very simple cut that we did in the National Engineering Policy Centre around a systems approach to decarbonising homes. So the central piece here is about decarbonising homes. Then you get the first layer of, well, how does that sit into new build and its design? What fuel sources can we think about? Is it a retrofit population of homes? What about energy sources? And then you build out from there, and you start to see the complexity of how this sits alongside grid interconnection. Are we going to have autonomous power systems? What fuel sources do we use? And I simply share this with you to say it's a standard engineering approach to get that systems map. And we need to get these layered system maps to understand where we need to intervene as quickly as possible. And you can see hydrogen getting played in here, land use, how carbon is removed from the system. So let me take you into very briefly home territory. Electrical power systems for me. A cartoon here of a traditional power system architecture. Centralized power station, energy up into transmission voltage is 400 kV, 275, through the network for transmission of supply, then down through distribution transformers into the end uses, whether it's industrial, commercial, or domestic, etc. And now we're talking about a much more complicated set of cartoons. Down there we've got wind power plant, embedded storage, we've got solar PV, we've got autonomous systems, and the UK Climate Change Committee also estimating, which is coincident with the Energy Systems Catapult, we could be trebling the load on the grid, the electrical load that is, by 2050, given that more heat and transport is going to be electrified. So let's bear that in mind. And people, because it's pretty static, folk take electrical transmission and distribution for granted. It takes decades to build this, and if you factor in planning and societal consultation, the Bewley-Denny line, you may remember that, Paul, that took about 12 years to get through planning. And I was involved personally in some of the arguments that were being made, because it's marching, these pylons are marching across private land. People are not happy with it, some people are. So when I talk about systems, regulatory alignment with what the government's trying to create, the smoothness and effectiveness of the planning processes there, and it just shows you the interdependency. If regulation is misaligned with what the government's trying to achieve, and Ofgem are in the thick of things just now, then we won't get things done. So bear that in mind too. Now, just for a bit of levity, let me give you an example of what the Power System 2000 looks like. So take this family multiple occupancy bike. This is them driving the power system. Use the bike for that analogy. So we've got large centralized power stations, hydro, gas, nuclear, coal, but less so coal in the future. Today, we've got a new mix. You can see this new appendage at the back, this youngster. That's mum and dad at the large centralized power stations. And the youngster is this new renewable deployment. But if we look forward into 2030, that renewable, much more distributed generation source is going to look like that. The system is going to be absolutely not replacing all centralized station, but it's going to look like very much more, and in Wales in particular, wind deployments, solar deployments. And the big thing I would say here is to get a low-carbon network innovation, to get a low-carbon network, innovation is essential. Again, engineers innovate, well, people innovate, engineers particularly innovate, and we need to get the innovation machinery properly played here. And I'll give you a quick clip of what, if I now really milk this analogy of a bike, let me show you what innovation can look like. So here's the small-scale generator coming up the back, trying to catch up with these large centralized generations. Innovation is required. I don't know who did the health and safety assessment on this one, but I'm going to leave it running long enough to let you see the expression. The last vehicle is a motorbike. I'm going to use that as an analogy for conventional thermal power stations. Just watch this guy. Do not try this at home, please. So innovating, taking risk, arguably taking a bit too much risk. But here he is, now getting to the front of the queue. Distributed generation, about to catch up with centralized generation. And hopefully in the back you can see the impact it can have on conventional technology. Anyway, innovation works, but again, I'll be careful about that. And then the electrical power networks, we're evolving. I mean, we're all familiar now with the offshore wind infrastructure. We're going to get much more AC and DC generation at I'm sure there are electrical engineers in the room. The holistic network design that's just been gone through, looking at a new 10 gigawatt subsea interconnected grid is important, but already it's probably under capacity that we require, but more DC generation. Same is going to be true for on-land transmission. Our own, just now, we're not quite constrained by 240 volts, 50 hertz at the socket outlet. Because of power electronics and control and new devices, we can have multiple frequency devices, some of which can be higher efficiency using mixed frequencies and control of the devices. And just think about the innovation that's been led over the past 20 or 30 years. In 1990, the typical wind turbine, that is about 500 kilowatts. And it was important, and we could see these spreading particularly across farmlands. And over the past 30 years, we're now looking at 15 megawatt turbines. Incredible engineering, advanced materials, structural design, new drivetrains, new machines, power electronics. For those that are deployed off-site, the civil engineering. It comes back to the honour that we're having tonight with the person for whom this lecture is named, the foundations, the manufacturing. And we're now talking about over 100-metre length blades, over 220-metre swept area across blade tip. Then we've got the device in water as well. So back to what we're saying about create industries, that this number's going up all the time. By 2040, the wind energy globally will be up to about a $3 trillion investment. It's fantastic. And I have to say, a lot of capability sits in the UK. What we haven't been doing is translating that into manufacturing and manufacturing jobs and O&M and service, but we're getting there. And the offshore renewable energy catapult, I was involved in establishing that, and up until last year I was the senior independent director on that. That catapult is doing a great job. And some really exotic things going on. Here's, will this be 15 megawatt floating wind turbine over the next 5 years. You send an army, and this is all completely doable just now and is being done. You send an army of drones out there rather than putting service vessels out there to have to look at it. Innovation, systems thinking, offshore grid, and there's some really exotic propositions which are some time off, like multiple rotor turbines on a spar that can be floated out to sea. There's always going to be the issue about power offtake. Do we do the energy conversion and bring it into grid, or we do gas conversion out there and get ammonia, get hydrogen? I'll show you a video in a moment. And again, some very interesting vertical axis turbines as well. And this is getting ratcheted up. That was, a couple of years ago, that was to be 30 gigawatts by 2030. It's now 40 gigawatts by 2030. It's driven through the net zero strategy and 10-point plan. So you can see, again, as I come back to these interconnectivities and systems thinking, manufacturing, design, innovation, infrastructure, grid infrastructure, policy, prioritization. How does Ofgem incentivize this? You may know that Ofgem and Innovate UK have just created a new strategic investment fund, which is innovation fund, which is really good, which is showing the regulator lining up with the need for more technological innovation to drive low carbon activity. And floating wind for me is, well, it's not there yet, but what an opportunity that is for the UK, because we really missed the first wave of wind in terms of anchoring, excuse the pun, the economic value here in the UK. But floating wind, in 15 years, we went from concept designs to real deployments. And the CEO of Equinor, well, he would say this, of course, wouldn't he? But we have to give him credit for the success of the company, that floating wind power could outcompete bottom-fixed turbines by 2030. And I'll give you a quick Scottish reference. In February this year, Crown Estate Scotland released the latest lease round, ScotWind it was called, and 17 projects were leased, and some additional projects came to the end, pointing towards, by 2030, 28 gigawatts of offshore wind. Peak demand in the UK is about 60, 65 gigawatts. Scotland, our peak demand is 6 gigawatts already with about 12 gigawatt installed capacity. If we got all of that Scot wind by 2030, which we probably won't, but let's make an assumption we got that, we'd have 40 gigawatts of installed capacity, 6 gigawatts of home capacity, so we need a lot of transmission capacity to transfer that energy across the UK, prospectively into Northern Europe and across Northern Ireland. So again, you see that need for the integrated grid to go alongside this. This is 5-6 megawatt floating spars up in Peterhead. Strathclyde were involved in supporting the electrical system design. Again, great engineering. You can see again, I read across here from the oil and gas sector, service vessels, deployment, subsea engineering, operations and maintenance. And back at the Catapult, technological innovation in the UK to deliver that net zero future. There's now a 15 megawatt drivetrain facility in Blyth. Remember Blyth, that used to be the new and renewable energy centre. It merged into the Catapult 7 or 8 years ago. Great engineering, great facilities. GE are bringing the machines in there. And what we're trying to do is not only accelerate low carbon energy, but to anchor jobs in the UK, build manufacturing plant built on UK innovation, testing and demonstration facilities. And look at this for a blade. This is blade tasting facilities helping to support us getting up to 15 megawatts and beyond. Massive, as many of you will know, materials science challenges. And then a company called Aker, you probably know from their oil and gas background, but Aker Offshore Energy are now looking at how do they recycle blades as they repower and seeing that whole circular economy around building big turbines, deploying them, and then as they're repowered or they're decommissioned, recycling the materials. So again, that whole systems approach, and I talked about the 3 Ds, decarbonisation, decentralisation, digitisation. These great robotic automatic inspection devices basically let them loose onto the blades, let them loose onto the structures. And of course, if you are 40 kilometres offshore, you want to minimise the personnel requirements to get out there and inspect. So measurement, control, communications. And to communications, here's a great project with a small company called Jet Connectivity, with a Catapult establishing a 5G offshore network in the Humber so that we can actually pick up. So a lot of these heavily censored wind turbines, and indeed the electrical architecture that sits alongside it, allowing companies like Jet Engineering to support that new generation of automatically well-managed, digitally underpinned assets. And there's going to be probably 4,000 to 8,000 offshore wind turbines at this scale over the next 10 years. Massive infrastructure. So let's use technological innovation to get there. And again, you can see this mixed mode. This is a Scottish Power slide, and I declare an interest. I'm Vice Chairman of the Scottish Power Board, but you're seeing here wind turbines coupled with solar activities. And if you can do that conversion locally, Iberdrola, this is the company that owns Scottish Power, you can see green hydrogen, where they're using Iberdrola, Scottish Power, now entirely green companies, they're renewables and grid. What they want to do now is work with some large industrialists to really stimulate that green hydrogen economy. And we need to see how that can be done. But marine is still there, and the UK does have a very strong leading position. I'll point to another part of Scotland up in the Orkney Islands, and that's the European Marine Energy Centre. I commend it to you. For technical tourism, it's a great visit. Orkney is a great place to be, and Neil Kermode, who's the chief executive there, would be delighted to have you visit. At any given time, they've got lots of different machines on trial. People would argue if a marine device can survive in the Orkney waters, it will survive anywhere. And you can start to see the players in here. Alstom's 1 megawatt tidal turbine device, Andritz Hydro Hammerfest. There's the electricity. That's a Strathclyde spin-out, by the way. That was a 200 kilowatt device. Actually, it was a tidal stream device. It was anchored, then it could actually follow the tidal stream flow. Orbital, really interesting device. You can't quite make it out. There's 2 enormous turbines that they drop down into the water, into the tidal stream, and Open Hydro, but this is an open turbine that can be dropped down underneath the water surface and then recovered for maintenance. And now EMEC are working on a hydrogen production system. You can see the cable lines coming in from a lot of these deployments, generating through electrolysis hydrogen and battery storage, so systems. Renewable energy, grid connection, ashore, electrolyze, use the hydrogen for local transport, potentially for other applications, getting a systems perspective. But this is a hard place to be, and wave energy is not easy at all. This is the Polamis device, which in that company is now sadly no more. Massive technological innovation, perhaps overestimated where they were on the TRL journey, probably thought they were about TRL 5 or 6, where they were really TRL 3 or 4. Really, I had a video here, sadly it's not working here, but this Polamis or sea snake device, it's got maybe 5 sections, and as the device articulates with the force of the waves, there are hydraulic pumps and compressors at those joints that drive hydraulic fluid into turbines, which in turn produce electricity and then go into an electrical collector and then out. Beautiful design. It just didn't work. You know, that's back to that risk appetite. We're not going to get it right all the time, every time, but we need to feed research ideas and get that acceleration through late-stage R&D into devices that work. And it started, I mean, again, this is not quite work. It started in the Edinburgh University test tanks and modelling. So that was a very simple Polamis model that ultimately led to that deployment. What happened there? Yeah. And now we're scaling. So wave is still, again, it's a tough place to be. Try to scale up to the megawatt range. But there's lots of great companies in there, Ocean Energy Buoy, rising water columns, tidal energy nearing commercialization now. And here's Atlantis Resources and Lockheed Martin. So for those, again, there's lots of engineers in the room. And you start to see that design convergence. You start to see a lot of different tidal devices looking like each other. So you can see that the engineering optimization is coming up with a set of devices. So it's going to be about value-added engineering and deployment at great scale, you know, multiple megawatts, and that's going to be important. Back to innovation briefly. You know, so it's not just going to be the big players. It's not just going to be GE or Alstom or ABB or whoever, Vestas, that's going to give us the view for the world. There's a small organization called MARIN, which is the Marine Research Institute in the Netherlands. Really visionary CEO. And here's his vision of a future of a low-carbon system that's tied in to maritime industry. This is interesting.
The wind and the sun represent a massive source of renewable energy, which is more abundant at sea than on land. Harvesting this energy will require offshore wind parks and floating solar panels, as well as wave energy converters, tidal turbines, and ocean thermal energy conversion. Processes are being developed to store the vast amount of renewable energy efficiently, in the form of hydrogen, liquid methane, or ammonia, for example. The availability of this technology offshore will be a game changer for shipping and harbors, creating entirely new maritime infrastructures. Large-scale wind and solar-powered energy and transshipment hubs will be located along major shipping routes. Small-scale energy production along rivers or in remote areas will also appear, redistributing the energy infrastructure. These energy islands could be used for renewable energy conversion and storage, but also as logistics islands, where cargo could be transferred from larger to smaller ships. Massive technological innovation will be needed if this is to become a reality, representing a true challenge for a number of industries. This energy transition means that communities all over the world will benefit from locally produced and stored renewable energy and environmental sustainability, and will remain connected to each other through zero-emission transport infrastructures. The shift to ocean energy hubs will not only support next-generation shipping, but will also open up the possibility of floating settlements. Rising sea levels in densely populated coastal areas are already forcing people onto the water. These hubs could provide a more sustainable and safe environment for these communities.
So who knows, but it's a vision. Driven by technological innovation, by the need to address climate change, and you heard that reference to those at risk on coastal communities. many of whom are women and children, let me say, because as often it's those that are most vulnerable in society that take the biggest hit for the vagaries of developed society. But very important and very interesting. And hydrogen, and I'm looking at my host, maybe 10 minutes and I'll take us through to finish, if that's okay. Because I could go on for much longer, but I won't. Hydrogen I'm starting to follow where the investors are. Technologically doable, economics still working on it, and I'm now seeing some very, very big players that are looking to make enormous investments in green hydrogen production infrastructure. And again, this is a plate out of a Royal Academy of Engineering activities. I'm sure you've all seen this, grey, blue, and green hydrogen proposition. Grey, which has CO2 emissions in the production of hydrogen. Blue hydrogen that comes, from either steam methane reforming or coal gasification. Blue hydrogen allows you to capture the CO2 on the way out and from the processing, that is, and green hydrogen through electrolysis, and that's very important. So the cartoon is there, but the key thing that the Academy, and I would commend you, please, to the report that we've just published in the past month, I think it is, looking at the role that hydrogen can play in a net zero energy system. It won't just replace natural gas all of a sudden. Is it going to be used potentially for high temperature industrial applications, transport, domestic heat? Who knows? But the key thing is we need to see how that systems architecture is going to work to produce hydrogen in the first place, what role it has, looking at low-carbon hydrogen production methods, and policy recommendations, because government has a very important role to play. Not just their money, but their money won't be enough. The rest of the money has to come from the private sector, so that has to be incentivised. But the policy incentives that get us going in this journey. And a couple of quick projects. One that I'll refer to, forgive me, is Project Orion up in Shetland. Led by Shell and Equinor, Scottish Southern Energy. We're involved, the Strathclyde's involved in the electrical system design, Babcock, Hitachi. Industrial excellence, great engineering, investment potential. And again, the vision here is about a whole system approach to energy supply in the Shetland Islands. As you know, through Sullom Voe, known as a global hub for oil and gas, but now on that transition to do renewable energy production of hydrogen, hydrogen distribution through transport on the island, and then using that to drive industrial processes. So these companies are committing to make that happen because, again, we can come to oil and gas. They're in a hot spotlight just now because of the major profits that have been made because of the way that oil and gas prices have gone. Windfall tax, that's for others to decide. But the energy transition, in my opinion, won't be achieved without them playing a much fuller part. They've got the balance sheet to support it. They've got the technical and engineering expertise, and they've got project delivery expertise that they can translate into this domain. And here is Orkney again. This is the Big Hit project, where again, you're getting small-scale electrolysis, tidal turbines generating electricity, hydrogen storage shipped down through these low-carbon ships, down into Kirkwall, into the main part of the island. Again, a systems perspective. So we can prove in the Orion project and the Big Hit project, they're big enough to be meaningful. You can take that systems perspective, energy production, distribution, transport, heating, and create jobs in the back of it. And there are many others that are underway. The green and blue activities, great project on the Acorn project, looking at the offshore large-scale production and then bringing it into St Fergus. There's just been a £400 million investment in the Aberdeen Harbour South. Incredible infrastructure, now getting ready to produce hydrogen that's being electrolyzed via water from the offshore wind turbines that are just off the shore there. Again, systems perspective. And up here in the Cromarty Firth, a lot of Scottish examples, forgive me, but it's the ones that I know best, but there's a lot going on in Scotland, let me tell you. When you see this integration with a substation here, driving and producing hydrogen offshore, bringing it ashore for distribution, etc., and others. So, last couple of things from me. I've been talking mainly about the supply side and that's important. But we can all individually make a difference to how we use energy and how we live our lives. So the demand side of the equation is very, very important. And that's about energy efficiency and energy reduction. Dynamic demand response. So, I mean, smart meters, I would commend it to you, but even as far back as 40 years ago, for those of you, I don't know if any utility folk in here, I don't know if you know Bob Peddy from Southwestern, was it South England Energy or something like that, came up with a thing called the Credit and Load Management Unit, using control signals. He got some of the spectrum off of BBC Radio 4. He was a utility director, and then he used that as a broadcast signal to control folks' heating and refrigeration because it had a thermal time lag. That was 40 years ago. But now with broadband everywhere and with control devices and smart meters, we've now got the opportunity to coordinate dynamic demand response to give good system management and flexible operation of grid and engaging end users, because we can't just do this to people. We need to bring them on that journey. And demand-side participation, very important, and lots of energy storage. So I am sure these slides are going to be shared with the audience, so I'm not going to go through every one of them. Is that okay? Big thumbs up. So let me take you through this. One thing I'll say here is, this is the Scottish Government energy strategy that Chris Stark was involved in producing, and it's some of that ethos that he's taken into the Committee for Climate Change, and that whole systems view, recognising that if we're going to get that transition, we need to integrate our view of heat, transport and electricity. This is a very simplified version of the Scotland requirement for demand. 53% heat. Well, you're in Wales, I think you probably get that as well. 25% electricity and the rest transport. And in terms of household use of electricity, space heating, a big deal. So we need to think about how we do that, including optimising the built environment, water heating, cooking and lights and appliances. So you can see in this climate, it's heat, and in other climates, it's cooling and the likes. So cities are very important. The places in which we live, Swansea, for example, already currently over half the world's population lives in cities, and that's going to grow over the next 20 or 30 years. Big sociological issues and socioeconomic issues. Cities are responsible for 3/4 of the world's energy consumption and 80% of the greenhouse gas emissions. So we can start here in the cities, which also in many ways, without getting into the politics of it, starts to give some devolved city leadership. My city of Glasgow, and it's a big target, and it was triggered by us hosting COP26, are saying they're going to be net zero by 2030. Now, that's a tall order, but if you get that political leadership, that commitment, and the private sector backing, you can get it done. So what I want to say to you, I've talked about oil and gas. We had to make pejorative comments. I'm not promoting them other than to say this journey is going to be an awful lot more difficult without their active participation in energy transition. And when you hear the CEOs of these large oil and gas companies talking about oil and gas and the need to do through the energy transition, and their shareholders holding them to account on ESG principles, then I think the positive motivation for them to participate. I'm going to go through to, and there's nuclear. And I'll just say that again, that, I think nuclear is bound to be part of the future. Offshore wind, solar, hydrogen production, storage, nuclear. You need that systems perspective. So my final comments are these. There is undoubtedly a need for international and national leadership and vision and commitment. And I'm going to give our political leaders the benefit of the doubt. Here in the UK, I hope that Chris Skidmore's review will reinforce and re-energise this commitment to net zero. The energy trilemma that I talked about, this play-off between cost, security and decarbonisation, is at the heart of all the challenges that we've got. I added the quadrilemma and the quintilemma there in terms of societal engagement and creating economic opportunity, viz. The Nick Stern review from 16 years ago. A growing recognition that we need a national engineering systems architect. We need a plan. We need to have something that we're aiming towards creating so that we don't block ourselves out through unintended consequences of choosing a particular technology or a particular architecture that stops us getting to that decarbonised future. bunch of words here, but they're important. Critically important, we need innovation. Hopefully I've shown some of that. Late-stage R&D, the Royal Academy's report on late-stage R&D about a year and a half ago had a big influence on the UK innovation strategy. But here in Wales, for example, we should, and I'm sure you are, creating late-stage high TRL demonstration capability that can take great ideas out of universities, take great innovators and SMEs and get them up to a productized, commercialized stage. Last COP26, the Academy, right in the middle of it, we published a low regrets options paper, which also is available on the Academy's website, which gives some guidance to government about choices to be made, whether it's on hydrogen, electrification, decarbonised grid, things, if we do scenario analysis, that we must have, regardless of what the specifics of a 2050 decarbonised future looks like. These are things that must be done. Investment, of course, Nick's proposition of a $2 trillion a year spending on this. It's incredible, but if it's done right, it creates jobs, markets, and economic opportunities. Aligned regulation, and I haven't said nearly enough about it, but I'll just emphasise just now, and we need great skills. And I'll make the case for engineers, but it's scientists, it's those that operate, and skills will be taken for granted. And when the 10-point plan came out, I wrote a letter via the Times on behalf of the Academy to say, do not take skills for granted, because it could be a great asset if it was there, but we're not producing nearly enough engineers and technicians from postdoc through to technicians in college trained, and we need a national strategy to generate the right set of skills to make us competitive, attract inward investment, and drive this low-carbon future and deployment. And if that in itself is a complex system. And importantly, action and pace, and let's locally keep our politicians to account, nationally and internationally, through things like COP26. And I will conclude by saying it is not just engineers, but certainly engineers that will build a new decarbonised future and that future energy system. And that will be a talented and diverse community of innovators. And there's no better productivity than a diverse and inclusive workforce, let me tell you. So let's let that one out there as well. And of course, engineers are problem solvers and systems thinkers, and that's exactly what we need to tackle the challenge. Thanks very much.
Thank you very much, Jim. So I'm here today. I have a few hats I wear these days. My name's Howell Thomas. I'm here today as a very proud member of Paul Boyle's team here in Swansea. And my claim to fame is I'm actually a graduate of the Zienkiewicz Civil Engineering School. I mean, there aren't many of us left, I think, but I'm one of them. And just to sort of win a few brownie points with Jim as well, I'm also a fellow of the Royal Academy of Engineering. So great to see so many comments and references to the Academy. We're going to have a Q&A session now. To start it off, I just think it's fantastic, Jim, the way that you majored this evening on the offshore sector. I don't know, you knew, I guess you must have known, there was a massive meeting down in the Celtic Manor today with something like thousands of people there, beginning to look at, how they can make as much money as possible and do everything they can for the Celtic field. And it's very relevant to this part of the world, obviously, with the ports of Milford Haven.
Yes.
And so I can't congratulate you enough on bringing that so much into the lecture, and to thank you for such an incredibly rounded and sort of well-spread lecture.
Thank you.
So my role is to try to get some questions answered. Is there a roving mic? Or so we just get started. Yeah, let's go with it. Could you say who you are, please, first of all?
Even though probably would not be. Okay, there we are. So my name is Francesco. I'm an associate professor in chemical engineering. Thank you very much for your talk. And I had one curiosity. A few years back, I attended a lecture for the Nobel Prize winner Stephen Chu, and he mentioned, and I was amused by that, the fact that cars were first introduced into Chicago for a simple reason, not because they were more efficient or whatever, to reduce pollution. And that's where we are today. because basically there was a shift in the problem from what horses were doing on the road to then the problem now we know moved up to the air. In the current strategy that has been developed and everybody that is working on, what are the systems in place to avoid that? For instance, we decarbonize the air, we can breathe again, and then we start polluting water, for instance. We'll be with the same problem in 20 years' time. So just wonder, like, out of curiosity, what is currently being done for that? Thank you.
It was my privilege to give Stephen Chu an honorary degree about 5 years ago, and when we were still travelling, I see him when I go to Stanford, and he's now moved his thinking into biomedical domain. I don't know if you knew that. He's a Nobel Prize winner physicist. So what's happening? You mean around electrical transport? Did I pick you up correctly? I heard reference to Chicago and transport and horse manure and things like that. Are you talking about electrical transport? Is that the question you're asking me?
Sorry, that was about when they introduced petrol cars instead of horses for transport to reduce pollution in the city, because horses were doing their business and somebody had to clean up.
Sure.
So in order to avoid that, they said petrol is much better environmentally.
Sure.
And they were wrong. We know now that they were wrong. So what are we doing now to avoid that a similar situation occur when, instead of saying, great, we know that cars now are bad, or decarbonization is our goal, and then we pollute other systems like soil and water, etc.
Thank you very much. So what you've just defined is a systems problem. And I think what you also emphasise is the need for ongoing scientific inquiry. One needs to understand, what the consequences are of, for example, cars, more energy storage, more batteries. Take a systems perspective, we need to mine those minerals, whether it's lithium, cobalt, iron. And mining mining was a bit of a whipping community. They were just about banned from COP26, which again was very unfortunate, because the mining industry needs to move to a sustainable means by which they extract minerals from the earth. Because if we are going to have this electrification commitment, and I think we have, we're going to need all these materials. So it's back to that systems perspective, and I think having understood that, as we look at the battery-powered cars, is it going to go to hydrogen? Possibly. But we need to make sure that the recovery of the materials, recognising that the particulate contamination, tyres and what have you, are pretty bad as well. And we're getting a lot of particulate contamination through transport on roads. So now we're discovering that, we need to think about new materials science that allows us to try and at least contain or minimise that particulate, what's the word we want to use, pollution, which comes from those. So what happens? You need to start with a vision and a design. So the utilities are very much pushing hard with regulatory support now to get the electrification infrastructure in place, so that when you turn up in what's currently a petrol and diesel forecourt, that you can also plug in your electric car. Back to that built environment example that I gave you, that complex systems diagram. If we are going to be building new housing developments, let's imagine what the transport infrastructure is going to look like over the next 10, 20, 30 years. So we put in charging infrastructure, either fast charging or battery storage, whatever it might be. So I can't tell you what all the consequences might be. What I can tell you from a systems perspective is we need to start off with a design. We need to continue with scientific inquiry to anticipate and understand issues as they emerge. And then we need to engineer solutions to either mitigate or remove what these impacts are. But what we're certainly going to have to do is decarbonise transport, not just on our roads. We need to decarbonise aviation. So sustainable aviation fuels are a big deal, and I'm sure Swansea chemical engineers have a view on that. More electric aircraft. Professor Sarah Sharples, who's the new chief scientist at the Department for Transport, excellent academic, has a particular focus for the moment, not exclusively, but a particular focus on maritime decarbonisation, because the maritime industry puts a very high proportion of pollutants into the global system. So if we can get fuel cells, even hydrogen production, you saw the Marin view of having this network of interconnected renewable islands, and you could get these ships to be picking up fuel as they're also delivering their cargo. So again, I'm a broken record, do forgive me. That systems perspective is key, and we have to anticipate through scientific modelling. Turing Institute's doing a lot of data-centric engineering just now, where you can do, I was pleased referring to your professor's background. There's now this notion of stochastic finite element modelling, where we can now couple digital twins with actual measurement. The more modelling we do, the more scientific data that we have, the more engineering of solutions we have, will minimise the risk of getting it wrong. But we must have a risk appetite to try and get it right, recognising that there will be engineering problems as we go. But if we play in solid engineering ethics into everything that we do, then we take these risks and these technological advances forward in the right way. That was a long answer, I do beg your pardon.
There's a question at the back.
Hello, I'm Dave Worsley from Swansea Uni. We're doing a lot of work as 3 universities in the region looking at industrial decarbonisation and decarbonisation of transport and homes as a complete system as you've described it. And there's some really exciting stuff going on with the local authority in Neath Talbot and Swansea. My particular question is around what your view is on industrial heat. You know, as we are close to Port Talbot Steelworks, we can't quite feel the heat coming from it, but the waste heat there is enough to power this whole region in a way, and as we move to introduce things like new nuclear programs, you know, there's going to be significant opportunities, I think, for waste heat. So I just wondered how that figured in your plans.
No, a great question, and I congratulate the collaboration that's underway. I'm sure you know colleague Mercedes at Heriot-Watt University. Is she part of the consortium? Or? Yep. So Mercedes, again, she's an inspiring engineering leader. I absolutely buy in and endorse this idea for us having to re-engineer how industrial processes actually work. It's maybe one of the early, excuse the pun, low-hanging fruits for the use of hydrogen into that high-temperature industrial domain. But for me, again, it's unintended consequences, and God knows it was for terrible reasons, but what we're facing in terms of supply chain problems just now and enormous hikes in energy prices, I think is going to drive change. And I think when the industrialists are looking at the price of a kilowatt hour of energy or a therm of energy heat that's coming out of the gas system, they're going to have to, if I quote Scottish economist Adam Smith's principles of enlightened self-interest, it's good to do the right thing. So climate change is an existential challenge, but when they're trying to maximise margin and profit in delivering their business plan, and their energy exposure is sky high, and they look around at the waste that they could probably afford over the past 20 or 30 years ago or so, then we have to redesign these things. So industrial decarbonisation, absolutely fundamental. As you well know, there are now very good policy interventions that are emerging to support the decarbonisation of certain industries. But in all of this, as well as great academic endeavour, we need industrial leadership. And I come back to what I was saying earlier about, Blackstone, Larry Fink, Blackstone. Somebody help me. Is that the BlackRock or Blackstone? I think it's Blackstone. Big investment house. 2 years ago, what he said was, unless his investment portfolio, and he advises private money into major FTSE and New York Stock Exchange stock, unless they can prove to them that their environmental and social and governance compliance and leadership is of the best, then he will not only not advise investment into those companies, he'll start to advise disinvestment from them. So another driver here is, I think the stock market and the investment community are going to start to cause bigger effects, because there seems to be an increasing authentic commitment to decarbonisation and sustainability that is going to work. So I commend the work that you're doing. I'm aware of a little of it, but I think the market is going to have its voice heard as well as policy. I lost sight of you there. You disappeared behind the guy in front of you.
So can we go for the last question? Can we get the microphone to the right on the other side so I can make the right difficult? That will be the last question.
Thanks, sir. My answers are too long, I'm sorry.
Hello. Hi there, Tristan Watson. Thanks very much for the inspiring talk. I wonder if you think there's a role for the democratization of energy in some of the systems that you've talked about, in particular things like local generation, social partnerships, social ownership. Yeah. Of course, the problem is huge. Do you think that there is a role to play for that?
Thank you for that question, because I occasionally put up my 4 Ds. Yeah. So my decentralization, decarbonisation, digitalisation, and democratisation. Yeah. Business schools would be proud of me with that alliteration, let me tell you. It's normally 4 Cs, is it not? But so is there a role for it? Absolutely. And that inversion approach that I took is something I'm talking a lot to Scottish Government about just now. So back in the early 20th century, 1910 to about 1920, in London alone, there were 18 different voltages and 15 different frequencies being supplied by about 40 different little local power companies. So they're a little power station, and they supplied the power to an immediately geographically local load. So my proposition would be that, and again, it's back to this need for a systems coordination. A lot of the standards in electrical systems just now are naturally very much focused on keeping the grid fully integrated. And when in fact, we don't really need to do that. In fact, there's good statistical model that will tell you under major system fault events, actually decomposing the network into multiple components actually gives you a much better performance in reducing lost customer minutes and disconnected load. So there is definitely an opportunity for that. There's in New York, I've just forgotten the name of the project, in one or two of the suburbs of New York, there's a major, they're quite enlightened in New York City, may I say. They've actually started to produce these collectives, and they're isolating electrical power supplies into homes. We've got some of that in Scotland as well, I have to say. So community-owned renewables, and I'm sure the same will be true here in Wales, where I've got friends that I've got a couple of wind farms and a hydro deployment near Loch Gilphead, Loch Fyne, for those of you who go there. Loch Fyne Oyster Bar, I can recommend it to you as well. I'll get the Scottish Tourism Board punch in here as well. But they've got maybe about 25 megawatts of wind and about 1.5 megawatts of run-of-the-river hydro. And about 20% of those turbines are owned by local communities. So they're getting the benefit. So that was, to be fair to my friends and their neighbours, they wanted to do that when they built the project. Also, I have to say, help them migrate through the planning process when the community saw it as an opportunity rather than an imposition. And I think that sociological thing is very important. And when people can see what it takes to generate electricity and its value, I think it makes them a wee bit more acutely aware about how not to waste it and to be seeing it as a precious resource. So I would say to you, I would fully endorse, societal engagement, community ownership where it makes sense, or even if you scale it up somewhere between national and local, a city-based system is important. And you can imagine Swansea having, for example, a power company that had its contractual engagement with the utilities and suppliers and engaged the local communities in the upside of the economics of it and very much the upside of the sustainability benefits that would bring in terms of reduced emissions, better health, low carbon transport, etc. So it's a great question, and I'm going to start using my 4 Ds again.
Thank you.
Well, thank you very much. Did I sit down?
It's my pleasure to hand over to Professor.
I'll put you into the light.
It gives me enormous pleasure to present to you the Zienkiewicz Medal. Thank you for such a fascinating talk. It's been absolutely inspiring to hear how important systems are going to be to address these very significant problems that we're facing today. It's been an absolutely tremendous lecture. We've all appreciated it very much, and you're a very deserving recipient of this.
Well, thank you very much. You're very kind. And I'm very proud of you. Thank you very much. Very proud. Oh, Rebecca's it. You picked up the photograph.